All right. My name is Yoav. Came here over from Israel yesterday. And today I want to talk to you about performance, how to tune up your React app. But actually, just before I start, I want to take a picture just for me, but it might also end up in the demo, so that would be cool if it works. So let's give it a try. Oop. Okay. So, smile. Cool. Okay, hopefully this works. Wi-Fi is working. Great. Okay. So I want to start by talking about measuring, how we can measure our performance, how we can optimize, so how we can fix our problems, and a little bit about media handling, more specifically about image loading and handling within our apps. And I have the short URL for the repo for this demo app that I'm going to show. Great, so this performance flow, this is what I call this little cycle here, is usually something we get into typically when things break or when we get a call, usually over the weekend, saying, there's a performance problem. So then we start measuring, we start optimizing, and so on and so on. So hopefully we should all realize that we should start earlier in the life cycle of our app. So let's talk about measuring. Why should we measure? Because performance really influences our user base and our customers. And it's been shown that customers abandon very quickly if our app doesn't work quickly enough and fast enough, or doesn't load fast enough, especially on a mobile phone. So we really want to put some emphasis on performance. If you look at this article from Google, 2 out of the 5 bullet points in this article talk about performance. So it's they're obviously putting a lot of emphasis on loading time and performance, and that also affects our SEO. So that's another important point. Now, without measuring, our app could be running like this, but it may be more closer to this, or maybe it's like a hybrid of it works sometimes, but I don't know what the hell this is supposed to be, but when it comes down to an Android device from 5 years ago, it may not be as quick as it should be. So they're going to get a very different experience than when we try our app on our MacBook Pros with 100 gigs of RAM and i70 something. So the point is, if we don't measure, we don't know. So let's take a look at this small app that I built for this demo. So it's going to load some images. Hopefully we'll see the one I just took. Cool, so here it is. Okay, and you could see that it wasn't so quick to load, right? And now I have this CPU throttling on, so I'm mimicking kind of a weaker machine that helps us figure out how our app behaves when we're not running the fastest machine possible. Okay, so let's see what happens when I click an item. Takes about half a second or almost a second to click, just select one item in my grid. So this is kind of Chrome's passive-aggressive way of telling us we should look into our performance. So we can use the shiny new React profiler. Just start recording, click an item. And we can see what happens is that my photos grid re-rendered just by clicking one item. And so did every single photo in the grid. So clearly we have a problem. And if we check the developer tools profiler, we can see a lot more information than what React sees. For example, how long JavaScript took to execute, but also this red bar at the top telling us that the frames per second has dropped, and this means that our user is going to get a less than optimal experience. But this is a pretty reactive way, sorry, pardon the pun, to measure performance, because we're doing it manually. So let's take a look at how we can create a kind of an integration test to test our performance. And for that, I use Cypress. So I have Cypress running here. And I'm just going to run my test. And it's going to load the app, and it's going to run this test. And I'm going to show you what this test does. Okay, so hopefully you can see the code. It's just going to visit our app, and it's going to find the first grid photo. It's going to click it, and then it's going to look for some information on the global object. So this Psi profile object that I'm going to show in a second. And it's going to look for the duration of the interaction, and it's going to expect it to be less than or not more than 16 milliseconds. So, and why 16? That gives us 60 frames per second, which is usually what we consider the optimal experience. So the browser has time to also listen to other events from the user and paint and do all the stuff that it needs to do. So we have the test running, and it's failing now because it can't find any profiling information. So let's go and add that. Okay, so I'm going to start by defining this profiler component. And I'm going to use the profiler component from React, which I think just now in 16.9 became stable. So I'm going to add my profiler here. And when we're enabling the profiler, we're just going to render the children, but it's expecting this onRender callback. So, oh, sorry. First, we define the onRender function, and you can see that it's getting a lot of useful information. For example, was it mount or update? And more specifically, actual duration. So how long did it take to run this update? And we get also this interactions set that's gonna we can examine. So if we go and do that, so what we're doing now, we're just iterating over the interactions, and we're going to store their information into the this global object that we've just seen. So now we have this profiler, and we need to add it to our application. So I'm going to do it here in my app component, and I'll just add it here. Okay. So now we're covered with our profiler, but we need this interaction information. So I'm going to add that to my grid photo so we can capture that click on the photo. So instead of dispatching just a normal action, I'm going to replace that with trace. And trace is actually something from the scheduler package from React. But this is still considered unstable, so hence the prefix. But actually, it didn't change over the last year or so, so I'm pretty sure it's going to stay similar. The API is going to pretty much stay the same. And what we're doing is we're giving it some kind of an ID, in this case, my action type. We're going to give it the start time, and then we're going to dispatch the action inside. So with that set up, we can go back to our test and run it again. And now it should fail because we have a performance issue. And this is the case, hopefully. I don't know if you can see this. So it expected it to run in under 16 milliseconds, and it took over 100. So obviously we have a problem, but now we have this kind of integration test that we can run all the time, and it's going to notify us when we have a problem. Okay, so I'll back to the slides. But you may think, well, doesn't React guarantee speed? I mean, they're all about speed. They do this fiber stuff, and that should take care of everything. So let's take a look, go back in time a little, and examine what they said on their homepage over the years. So if we go back to 2013, the word efficient was right there in the middle. Actually, and then in 2014, they started saying, well, ultra high performance. So that was promising. And it stayed for, and actually that didn't stay too long. It became just better performance. And fast forward, and it's still there, but now from 2017, it's gone. So there's no promises anymore for speed. And that's the same, and I actually checked this morning, still the same, no mention of performance. Okay, so why can't they guarantee speed? There are a lot of things that take place with our apps that really are outside the React control, whether it's the connection speed or the device we're running on, but it really comes down to our implementation in our JavaScript. So no matter how good React is, it cannot really guarantee the speed. So it's up to us to really understand what happens when we do different things and how we can improve it. So kind of making sure we know the pitfalls. And speaking of pitfalls, the next section I want to show you different pitfalls and how we can fix them, either by fixing our code or using different tools. So just diving back right into the code. Okay, so what we saw when we clicked an item, we saw that everything was re-rendering. So my entire grid was re-rendering for every selection I made. So obviously, that's something we should focus on. So we see what happens when we're clicking the image. If you want to see the on click here, we have set highlighted, and we're just dispatching the ID of the photo and whether it's highlighted or not. So let's go into our reducer, see what it does. In this case, we are talking about Redux, and as you might have seen earlier today, MobX can probably solve a lot of these issues, but we're still a lot of applications are built with Redux, and with Redux we're usually using immutable data structures. And immutable is great. It protects our code. It protects our data from making changes outside of our reducers, but it also has pitfalls, and we should be aware of that. So in this case, what I'm doing is when I'm setting the highlighted value, I'm doing that inside my photos array. So I have this array of photos, and it's of objects basically, and I'm going to change the highlighted flag inside it. And what this does, it's going to change all those object references, and then even something like pure component or memo can't really help us because that strict equality is not going to see the similarity, and we need to be careful. Okay, so let's change our data basically, and what we can do is we can move the highlighted flag to higher in our data structure. So in our state, I'm going to define this highlighted photo ID, and I'm going to store the flag there. And when I do that, hopefully, okay, so now I've done that, and I need to make sure also in my grid photo, I need to change the way I pass along the flag. So let's change that. Okay, so I'm going to use a selector. So this is from React Redux. And I'm going to select the highlighted photo ID, and then I'm going to just compare the highlighted ID with my photo ID. Okay, so that should work, right? Okay, let's refresh. Oh, I'll turn off the throttling so it's not too bad. Okay, and let's record. Click an item. And okay, so photos grid didn't re-render, but still all of my grid photos re-rendered. So what's going on? Can someone spot the problem? And this is actually something I found in a production app not so long ago. So it's not just a contrived example. This is actually an issue we found in production. And the issue itself is that we are selecting a different ID based on the changes the user makes. So every time we make a change, all of our grid photos are seeing this change and therefore re-rendering. So what we need to do is basically do the comparison inside our selector. And just change the variable name. And let's see what happens now. If I go and record, select stop. And now I have just one single component re-rendering while all the rest are not. So that's a big improvement. That's our this is the part about immutable data that we need to be very careful, and how we select our data is also very important to protect us from unnecessary re-rendering. Awesome. So now I'm going to move right on to memoization and selectors and memoization. So thanks to Lydia, I think you're all now memoization experts. And I'm going to just show you that our selectors, while usually are very small and should be very small and fast, they can sometimes grow to be more complex. And we need to understand that they run even though our render function or our render components rendering functions don't get called, our selectors usually do. So they are running much more than we may expect. And to prove that, let's just add a console log to our selector. So it's the same selector, it's just gonna log every time it's called. Okay, so we're not re-rendering the component every time. Obviously, the first time, let's try and make this bigger. Nope, here's better. Okay, so we can see that the first time the page loads, we are going to call our selector for every grid photo. But now I'm going to make a selection, and we can see that it's still being called all the time, even though only one of the photos re-rendered. So what can we do about that? Again, imagine this selector being more complex than just returning or just comparing an ID. So what we can do is we can, what we want to do is we want to memoize our selectors. So we want to cache them so they don't change or they don't run unless the data they care about changes. So we can, there are different memoization libraries. I'm going to use reselect, and which basically allows us to build selectors, but it also memoizes all of our selector functions. Okay, and so it's doing. Okay, so we've seen this before. This was causing a problem, right? Because if we just select the ID and return it to our component and do the comparison inside, we're going to have the re-rendering problem. So this is not going to be useful. Let's try a different selector. So now we want to have a selector that does the comparison inside. Now, our selector is defined outside of our component. So we need to somehow pass the photo ID to our selector. What's the problem with that? With Connect, it's easy. Connect allows us to pass the props, but useSelector doesn't. So what we need to do is we can use callback. Let's go and define it. And we're gonna call our selector inside our use callback. And now we're just gonna pass that to our use selector. So now we should be okay, right? Well, let's take a look. First time, everything runs, but then also for each selection. So I select and it's still running all the time. So what we need to understand is that we have, in this case, 200 photos in our grid, 200 components. They are all sharing one instance of the selector. And that's why its caching mechanism basically can't find a matching result, because most memoization libraries and reselect as well uses a cache size of 1. So when we move on to the next component, it's going to see different data, and it's not going to be able to be effectively caching anything. So what we need to do is we need to create an instance of our selector for every instance of our component. Now we can increase the cache size, but that's a slippery slope, because we don't necessarily always know how many items we're going to have. And we don't want to have a huge cache that's going to blow the browser's memory. So let's see how we can do that. So let's get rid of this. It didn't help us. And I'm going to show you this custom hook that I built. And what it does, it receives a selector creator, or like a selector factory. So it's going to memoize an instance of a selector, and it's going to make sure that useSelector always sees the same function as long as the data didn't change. So what we can do is now we can go back to our selector and make this into a selector factory, and we're just going to make that a function that returns the result of create selector. And then we can just pass that our selector factory with my photo ID, and let's see what happens now. So the first time we're going to see all of our selectors being called, that's expected. But then the next time, well, it's only being called once. And then only for those components that we render, we're going to call it. So that's a lot better. Great. Okay. Next topic. I really wanted to get more into hooks, but I'm afraid I don't have enough time, and I want to show you also some media or image handling tips. So I'm just going to show a quick tip that I just recently learned, and I'm not sure if many people are familiar. So no, let's keep that. Okay. So let's say we have my state, and we're going to use state, and let's use a function to create our state. So let's say we have this function that builds an object or something for our state, and it might involve some calculations. So we don't want this to run more than it needs to. So I'm going to use, I need to go ahead and use state. Great. And just going to pass my create my state result to use state. Now, what happens, and I've added a console log, so we'll see how many times it's going to run. So we see that it runs for the first time for all of our components. So it's going to run on mount. But let's see what happens now. So I've re-rendered this component, and this function was called again, and again, and again, and again. So this function is always going to be called, even though it's already mounted. Now, the tip is that we can pass a function and then call create my state. And when we update, so again called for the first time, but now when we're, this is from our selector, so we don't see the create my state call anymore. How many were familiar with this? Okay, so a few, but not many. Cool. Okay, next topic, real quick, windowing, virtual scrolling. So if you're not familiar, the idea behind windowing or virtual scrolling is that when we have a big list or a big grid, we're not going to render all of it at once. We're actually going to just allow the user to scroll and replace the item in the DOM as the scroll goes on. So this gives us a very small and slimmer DOM with a lot less components to update, and that can really bring performance improvements. Oh, just almost forgot. I forgot our test. So now when we go, after all of our changes, when we go and run our test, well, now it's passing. And if you remember, we were at, I think, 117 milliseconds, and we're now down to 2.5. So that's a huge improvement just by making sure we're not re-rendering unnecessarily. So forgot to show you that. Okay, back to window. We can actually, in the wild, see the difference. If we go to Drive and we load a folder with a few hundred items, we're going to see how sluggish it gets. While Google Photos is using windowing, and it's a lot faster, a lot slicker. It just loads a couple, maybe 20, 30 photos into the grid at one time. So I'm running late already, so I'm going to try and be faster. Hopefully you can see everything. Okay, so I'm going to switch to my windowing branch because I needed to set up a bit of a styling change for window to work. Obviously, up until now, I was using this flex grid, and now I'm going to use a window grid. Okay, so to get it started, I'm going to use an autosizer component. And what autosizer gives us is just the size of the container we're going to render the grid in. And if it changes in size, it's going to update our grid. So let's remove this. And with Photos Grid, what we're going to do, so I'm going to use React Window, which is one of the main windowing components for React. This is from Brian Vaughn, who also built React Virtualized, if you're familiar. So we're going to use the fixed size grid from React Window. And we're going to just replace our the map function with React Window. So render grid. Cool. So now we have a grid, and we need to tell it how many columns to render, how many rows to render. So we need some calculations. Grid counters. Okay, so we're going to calculate based on the size, the width of the elements in the grid, and how many items we have to also get the row count. So we're going to pass col count and row count to our grid. Then we just need this helper function to get the item index from our photos array. And I'm just gonna, if you're interested, it's just doing simple calculation. So inside this function, the children function, we're going to render our grid photo as we did before. Okay, go back to our page. And now we have a pretty much the same grid of photos, but if we examine the DOM, okay, so we have this list of elements, and as we scroll, they're going to be replaced by new ones. But the scroll is very slick, very fast, but we're actually only keeping a certain amount of items in the grid at any moment. Okay, so that was React window. I'm not going to go into build and delivery. This could fill several talks, but if you're interested in all these concepts like time to first byte or critical rendering path, I really suggest reading these because these really influence the load time of our app. So code splitting and all sorts of techniques to improve speed. So the first link here is very useful. And I'm just going to run into the media handling. So full disclosure, I work for Cloudinary, and what we do is, a lot of what we do is optimizing media for online applications and websites. And I'm just going to run quickly. As you probably know, images is the heaviest, in terms of what websites deliver to their users. Images take the biggest part. So if we look at the top 10 percentile, images take up 75% from the bytes that websites send down to the browser. Okay, so what can we do to really optimize media or images in our application? We can reduce the size, we can choose the best format, we can make sure we're rendering responsive images so we don't send too many pixels if we don't need them. We want to maintain the aspect ratio of our photos, and then we can also use some lazy loading to really make sure we only send down the bytes that the user is going to see. So let's go back to the code, and where's my mouse? Okay. So let's go back to the demo branch. And in my grid photo, so I'm just going to be very, very quick about it. I'm going to define, I'm going to use this, oh, sorry, let's bring it first. So I'm going to import this utility function, get responsive attributes. So I don't know about you, but I really hate coding source set and sizes attributes. It's the worst nightmare because I can never remember how to type it. So I just have this this utility function that's using the Cloudinary SDK to create those. And I'll need to use memo as well. Let's add that. Okay, so I'm going to use this this utility function, and I'm going to pass the photo ID, so Cloudinary knows what photo we're talking about, and I'm going to ask it to build a few URLs for me between 400 and 800 pixels, and I'm going to use crop fill, so make sure that the aspect ratio is maintained. I'm going to use DPR2 in case, you know, for mobile apps we can use that for better resolution. I'm going to ask Cloudinary to give me the best quality of images it can, and but also reduce the size as much as possible. And I'm going to pass in fetch format auto, so it's going to decide for me what's the best format and it's going to get the best size for the browser I'm using. And once I have this, I'm going to pass along the sizes and source set attributes, and let's see what happens when we do that. Okay, so if you take a look, so here we have all the source set and sizes built for us, and you know, without ever having to remember those the way we need to code those. And if we go and check what kind of image we got, so in this case we got a relatively smaller image than the original one, and it's still pretty big, but we can also tweak the sizes a bit. But if we go and let's see, get the image address, and if we look at, if we take out all the, of course this is DPR2, so it's going to get more pixels than we actually need. And but if we look at the photo, at the original photo, we're going to see, let's take a look. And you're going to see that the original image is, let's see here. Okay, so it's a lot of pixels, right? And it's over 3 megs, so we got it down to 100 kilobytes. And that's obviously a lot better than retrieving a lot of photos with a few megabytes each. That's going to take a long time to render. Okay, so final point. Chrome just shipped with image lazy loading, so we can introduce that for our images. What we want to do is we want to say, please load it lazily, so we use the lazy value. And we probably want to passing some initial values for the browser to not reflow as much, because otherwise, before the image loads, it doesn't take up any space, and there's a lot of reflowing, and also it's going to be less effective. So with that, what we want to do is we want to clear cache, because lazy loading is only applicable to non-cached images. And if we go into our network tab, we can see that what it loaded was only 60 images out of the 200. And as I scroll, it's going to ask for more images. So now it's getting more. And there's no JavaScript at all. So it's just a browser, it's just Chrome doing its job. So this is really cool, good news. But this is good for Chrome. Other browsers don't have this feature yet. So what we can do is we can use a React component for lazy loading when the native one isn't available. So let's go and add that. So what I'm doing here is I'm checking if it supports lazy loading by checking the HTML image element prototype. If it doesn't have loading in it, we know it's not supported. So we're going to render this lazy load component from React lazy load. Okay. Oh, it's angry about the imports here, so let's move them up. Okay. And now all we need to do is we go back to our image, and we're gonna use my lazy loaded image, and we don't need the loading here anymore because we have it back here. Okay, so we have loading lazy for Chrome, and for all the rest we don't. So we can go check how it looks in Firefox, hopefully. Okay, Firefox is not responding. Nope. Okay, but it works, I promise. Let's try again one last time. Okay. Whoa. Whoa. It's not so good about the loading part. Okay. So if we go and inspect, so we don't have lazy loading from natively. So, but we do have it with our with the lazy loaded component, and we can see we have very few requests. And as we scroll along, we're going to lazy load those images, so we get more requests as we scroll. And for the user, the experience is seamless. Okay, we did it. Thank you very much.